Hi everyone, this is your Dr. Bitla Venu. In this session, we will discuss the projections of the solids. In my last session, we have discussed the projections of the points, lines, and we took some examples to draw the projections of the points and lines. But in this session, we will discuss the projections of the solids. Then in this session, in the first step, we will see the different types of solids, how the solids will be generated and the terminology related to the solids. Then we move further to discuss the approach to solve the problems on solids, projections of the solids. Then, then I am following in this session, I am going to discuss the three-step approach to solve the problems to draw the projections of the solids. Each step we will discuss, and we will also discuss the terminology related to the solids, then the approach to solve the problems we will discuss. Then I will take few examples by using the approach to draw the projections of the different types of solids. Then let me move further to see the terminology or the introduction related to the solids. Then let us try to understand the terminology related to the solids and as well as the what are the different types of solids. Basically, the solids are classified and arranged into two major groups. Uh, Let me group A and group B. And the group A and one group is that the top and base is having the same shape. I'm grouping this as group A. And group B, the other group is that the base is having some shape and the top is having the point. Point is nothing but an apex. So base is having some shape. It can be circle, it can be hexagon, it can be square, anything. But at the top we have a point that is called apex. So that is group B. So there are basically two types of solids. One group, in one group, the base and top is having same shape. Base and top is having same shape. But whereas in the other group, the base is having some shape, but the top is having some point. So that point is also called apex. So when the base and top, take an example. We take the cylinder, consider the cylinder. The base and top is having same shape. As you can see here, it is circular shape. Then in the case of the prisms also, as you can see, it is at on the top we have triangle and the bottom also we have triangle, and the top square, then bottom square, pentagon, hexagon and hexagon, and all these are the prisms. That means in the prisms, in the cylinder we have the circular shape, top and bottom, but whereas in the case of prisms we have, it can be triangle, it can be square, it can be pentagon, it can be hexagon, or the octagon can also be. So that means the cross section is uniform along its axis. Throughout its length, the cross section is uniform in group A. The one type of solids, the first group of solids in which the cross section is uniform. That means the top shape and as well as the bottom shape is same. So as you can see, cylinder and as well as triangular prism, square prism, pentagonal prism and hexagonal prism. So when we have the 6 sides, it is a hexagonal, then 5 sides pentagonal, then 4 sides it is a square prism, then it's a 3 sides we have the triangular prism. So in prisms we have the bottom shape and top shape is same, and as well as the cylinder also the bottom and top shape is same. And similarly, then you can also take the cube. All the sides are equal. A solid having 6 squares and 6 faces which are equal. in its dimensions is called cube. Now let us see the group B. As you can see, cone is having one apex, the bottom is cylindrical in its shape. Then you consider the pyramid, then all these are pyramids and these are the prisms. You can see here triangular prism, then square prism, pentagonal prism, hexagonal prism. That means based on the bottom shape, we are going to name the type of pyramid is that. If the bottom is having three sides and triangle in its shape, then we are going to call that as triangular pyramid. Then if it is four sides, then we are going to call that as square pyramid. If it is five sides, pentagonal, and six sides, it is hexagonal pyramid. It is hexagonal prism, hexagonal pyramid, pentagonal prism, pentagonal pyramid, triangular prism, triangular pyramid. Like that, we have the naming convention. So on the top, we have point or apex. On the bottom, we have the definite shape. Based on that, we are giving name. So this is, and we have another shape that is tetrahedron, in which the four triangular faces equal four triangular faces, that is called tetrahedron. Now let me move further to see the terminology related to the solids. Now terminology, and as well as the it can also be termed as dimensional parameters of these solids. These parameters are the nomenclature normally we come across while solving the problems. Then I'm taking the square prism, square pyramid, and cylinder cone. Then take all these, consider all these shapes. Then the top face is called the top face. Then bottom face is called the bottom. Top face, it is having, as this is normal terminology, but we have one rectangular face. Then we have the longer edge. Then we have the corner of the base. This can be corner, this can be all, and it is having the four corners. Corner of the base. Then this is called the edge of the base. As you can see, this one, this one, this one, the edges of the base is called the edge of the base. The corners of the base is called the corner of the base, of course. Then this is actually the base. Then this is apex. Then it is called the slant edge. The slant edge we will come across in the case of the square pyramid, or the pyramids will come across the slant edge. Then you can see the base, then we have the base edge, then the base corner, corner of the base, then we have the triangular face, yes. Then when it comes to the cylinder and cone, we have the imaginary lines on the surface of the cone and as well as the cylinder. These imaginary lines are called the generators. Generators are the imaginary lines which are responsible for generating the surface of the cylinder and as well as the cone. These cannot appear, these are not visible to our eyes, even though we are imagining the lines which are responsible to generate the surface. So that we are calling these lines, these imaginary lines, as the generators. As you can see here, the imaginary lines which are responsible to generate the surface of the cylinder or the surface of the cone is called the generators. Now the bottom is called base. Then in the case of cone, the point is called apex, obvious in the case of pyramid, and as well as in the case of cone, the point we are calling the same name, that is called apex. Then it is a base, same terminology. Then the other terminology related to the solids is that when we do the section of any of the solid that we are discussed as of now, the section plane which is not parallel to the base, the surface that we get is not parallel to the base, because we're not making the section of the solids, as of now we are discussed, when we do the section this with certain angle, the surface that we get, our exposed surface, is not parallel to the base. So those type of solids are called these sections of solids. That means when we do the section of the solids, the section plane is not parallel to the base, then the top and bottom faces are not parallel. So in which we get some inclination. That means these two are not parallel. So these type of solids are called the sections of solids. That means we are making the section of a solid which is not parallel to the base is called the sections of the solids. Now let me move further. When we do the section in such a way that the surface that we get is parallel to the bottom face is called the frustrums of the solids. As you can see, the frustum of the cone here, frustum of the cone here, and frustum of the pyramid here. So in this case, the top and base are parallel to each other, as you can see here. So when we do the section for these solids, as of now we are discussed, the section plane is parallel to the base. Then the then the solids that we get after doing the section is called the frustum of the cone or the frustum of the pyramid. That means in this case, the section plane is parallel to the base, but in this case, in the case of sections of solids, the section plane is not parallel to the base. It is going to make some angle with the base. That is called the solids that we get is called the sections of the solids or the frustum of the cones. So let me move further. These are the terminologies related to the solids that we come across while solving the problems. Now let me move further to see the examples. Now I'm considering a cone which is standing on HP on its base, standing on horizontal on the ground. Otherwise, we can also in some problems in the problems they dictate us a solid is lying base on its HP or on the ground. That means it is also known as HP. Now, when it is standing on HP, so and XY in this case is the horizontal plane. When we see the horizontal plane from the front, it is a straight line or a horizontal line. I'm indicating this as XY. Now, when we see this, when a cone is resting on HP, when we see from the front, and it looks like a triangle, and in this case, and I'm locating the cone such a way that its base is resting on HP as well as its axis is perpendicular to HP. When we see this cone from front, it is a triangle, as you can see in this figure. Then, as I said, the axis is perpendicular to HP. When a cone is resting on HP on its base, then the axis is parallel to VP and axis is perpendicular to HP. In this case, when a cone is resting on HP in such a way that the axis is perpendicular to HP and parallel to VP, it looks like this. That means the front view looks like this. Then I'm placing a cone. A cone is placed in such a way that the axis is making some angle with HP and the axis is parallel to VP. The front view of the cone looks like this. As you can see here, the axis is making some angle with the horizontal plane, that is XY, and the axis is parallel to VP of this cone. When we see this object from front, it looks a triangle and its axis is making some angle as well as this axis is parallel to VP. So this is a case resting on HP such that one of the edge of the base is touching on HP or lying on HP, and its axis is making some angle with HP and the axis is parallel to VP. When we see the object, in this case it is a cone. When we see from the front, it looks like this. As I said, the axis is inclined to HP and parallel to VP, and this is the front view of the cone. In this case, in these conditions, then the third case is that the axis or this cone, the generator, the slant side, otherwise the slant side, so one of the slant is lying on HP or resting on HP, and axis is making some angle with HP and the axis is parallel to VP. This is the case when we see the cone from the front. When it is lying on HP, one of the generator is lying on HP and the axis is making some angle with HP and the axis is parallel to VP. In this case, it looks like this. This is the front view of the cone when the axis is making some angle with HP. Then the one of the generator is lying on HP and the axis is parallel to VP. The front view of the cone looks like this. Now, in these three cases, I have considered a cone is resting on HP. I have drawn the front view, but now I am considering the same example. Now the base is lying on VP. Now you can see here, now the XY I am assuming as a vertical plane. That means I am observing from the top. So the vertical plane looks like as a XY line or as a horizontal line because I am observing the plane, vertical plane from the top, so that we will get a straight line. Now I am observing from the top, so the XY represents a line here, straight line here, as you can see. Now the first case is that the base is lying on VP and the axis is perpendicular to VP and parallel to HP. The top view of the cone looks like this. This is the top view of the cone when the axis of the cone is perpendicular to VP and the base is lying on VP and the axis is parallel to HP. As you can see here, axis is perpendicular to VP and parallel to HP. The top view of the cone looks like this. This is the top view. Then the axis of the cone is making some angle with the vertical plane and the one of the point of the base is lying on VP. Then the top view of the cone looks like this. As you can see, the axis is making some angle with VP and it is and one of the point of the base is touching or lying on VP. When we see from the top, it looks like this. As I said with you, it is resting on VP. One of the point of the base, a circle, is lying on VP and it is making some angle. The axis of this cone is making some angle with VP and the axis is parallel to HP like this. This is exactly the top view in these conditions. Now the other case, uh, one of the generator, one of the slant of the cone lying on vertical plane and the axis is making some angle with the vertical plane and parallel to HP. The top view of the cone looks like this. These are the three cases. In these conditions, in these three cases, as I said with you, the base is lying on HP. In the first case, as you can see here, the base is lying on HP completely and base is parallel to HP and the axis is perpendicular to HP and parallel to VP. And in the second case, I consider the bases are lying on VP and axis is inclined to VP and parallel to HP. But in this case, axis is parallel to VP and inclined to HP, as you can see here. Right. Now let me move further to see how to solve the problems. I'm following the three-step approach to solve the problems. In the first step, assume solid standing on the plane with which it makes inclination. Now we have to consider that on which plane the base is lying and from which plane the base is making some angle, that we need to consider. If it is inclined to HP, assume that it is standing on HP. If it is inclined to VP, if it is inclined to VP, assume that it is standing on VP, like this. If a solid is making some angle with HP, assume that it is lying on HP. If the solid base is making some angle and with VP, assume that the base is lying on VP, then proceed further. If standing on HP, it's top view. If the base is standing on HP, the top view will be the true shape, and top view will be the true shape, its base or top. Then if it is standing on a VP, its front view will be the true shape of its base or top. Okay, then begin with this view, because we have to begin with the true shape. First we have to draw the true shape, then we have to use that true shape projections to draw the front view or top view respectively. If the base is lying on HP, top view will be the true shape. If the base is lying on VP, the front view will be the true shape. That means we have to draw the true shapes first based on this decision. Then, so its other view will be a rectangle if the solid is cylinder. If the solid is cylinder uh, lying on HP, the base is lying on HP, top view will be the circle and front view will be the rectangle. That's what the meaning of this sentence. Uh, then if other view will be the triangle. So if the solid is cone, the base is lying on HP, front view will be the circle, the top view will be the circle, and front view will be the triangle. Okay, so if it is a pyramid, base is lying on HP, front view will be the shape of the base, that means top view will be the shape of the base, then front view will be the triangle. We have to proceed while solving the problem. First step is we have to draw the true shape first, then use the projections of the true shape to get the front view, then use the front view to twist, and whatever the values, whatever the inclinations that is given in the problem, to draw and use those points, projected points from the true shape, to twist the object to the desired angle. This is what the first step. Then the second step is that we have to, after drawing the true shape, then the front view by using the true shape. If it is a top view, then we have to project the front view to get the top view to the front view. If the front view is the top, a true shape, get the top view from the projections of the front. Then after, in the second step, we have to assume the inclination angle of the base or the axis. Then in the final step, draw or consider the inclination of the axis of the object with reference planes. So to that we have to draw the front view and top view. Now the general pattern we will see, I will consider few of the examples here. As you can see, I'm considering one group and two groups here. Okay, then as I said just now, if a cone is resting on HP, the true shape is top view. Then draw a circle, then use this circle, and the front view we will get the triangle, as I said with you. Then we have the height, we have the diameter, and take a point here, then join these the inclined lines to get the front view of the cone. Then when the axis of the cone is making some angle with HP, then I draw a line which is having some angle, which is making some angle with HP, and construct the same shape, whatever we have in the front view on the inclined line itself. Okay, so we have this length, take a compass and get the length. Of course, in this case, it is a definite length, get the length, then take a compass, intersect this center line to get the apex, then join these to get the triangle at the desired angle with the HP, and project all these points down to get the top view of the inclined or the twisted top view of the cone. Then if the angle, I mean if the axis is making some angle with VP, but in this case it is having some angle with HP. Along with that, this is the first condition, and the second condition is the axis of this cone is also making some angle with VP. So draw a line with certain angle, with a given angle, then uh, just exactly project whatever the points here on this line. The shape of this and the shape of this is same, except that it is twisted to the angle. That means with the vertical plane, the axis of the cone is twisted to some angle here. Then project all these points top to get the uh, top view. Sorry, it is a front view. It is a top view and it is the front view. So project all these points to the top to get the front view. And similarly, in this case, as you can see here, this is a cone, but in this case, a cylinder is lying on HP. The top view is a circle, front view is a rectangle, and similarly, this cylinder is twisted in such a way that the point of the base point of the cylinder is lying on HP, and the axis of this cylinder is making some angle with horizontal plane, and draw the projections for this, and similarly the axis of this cylinder is making some angle with VP. The cylinder axis is making some angle with HP as well as it is making some angle with VP. So we have three projections here: when it is perpendicular, when it is making some angle with HP, when the axis is making some angle with VP. In these three cases, we have drawn the projections. We have to proceed further. So the shape of this shape and this shape is same. When the axis of the cylinder is making some angle with HP, the top view, and when the axis is making some angle with VP, these two top views are similar, except that this is horizontal here and it is making some inclination with the vertical plane. And take the compass and project all these points to get this shape. Then project these points top to get the front view. Then as you can see here, so these are the two cases that were considered when the base is lying on HP and it is making some angle with lying on HP such that the one of the point is touching with the HP or lying on HP and making some angle with HP, and the axis of this also in these two cases also making some angle with VP. So this is the case. Now you can see here. Now the same cases we will consider. But in this case, the base of this cone is lying on VP, but here the base of this cone is lying on HP, but here the base of this cone is lying on HP such that the axis is perpendicular to VP. As you can see here, this is the vertical plane. This horizontal line is a vertical line. When you see from the top, this plane looks like a straight line or a horizontal line like this. When you see from the top, such that this cone is lying, the base of this cone is lying on VP, so that we will get, in front view we will get a circle, but in top view we will get triangle, the vice versa in this case. As you can see here, in this case the top view is the front view is a triangle, top view is a circle, but whereas here front view is a circle, top view is a triangle, exactly vice versa. In this case, the base of the cone is lying on HP, but in this case, the base of the cone is lying on VP and the axis is perpendicular to VP and parallel to HP, as you can see here. Now, the axis is twisted to some angle with VP, and finally the axis is also twisted to some angle with HP, and draw the projections with these conditions. And similarly, a cylinder base is lying on VP. If the cylinder base is lying on VP and axis is perpendicular to VP and parallel to HP, in this case, the top view is a rectangle, front view is a circle. And similarly, the axis of the cylinder is making some angle with VP. In this case, use the projections of this front view to get the inclined surface here. Now, the axis is also making some angle with HP here. It is making some angle with VP and it is making some angle with HP. Project these lines. Project these. First, we will get these two. Then we will get this one, and from this we will get this shape. Then we have to project this, we have to twist this to some angle with VP and use these projected points to get the top view here. This is the approach we will use to solve the problems. Now, let me take one example here. Let me take one example. Now, let me take one example. So I'm considering one example here. A square pyramid, 40 mm base side and axis is 60 mm long, has a triangular face on the ground. That means the triangular face of the square pyramid is lying on the ground, means on the HP, and the vertical plane containing the axis makes an angle 45 degrees with VP. That means the axis is making 45 degrees VP, and the triangular face is lying on the ground. So with these two conditions, we need to draw the projections of the square pyramid of base 40 mm and height 60 mm. I read out the problem once again. A square pyramid of base 40 mm side and axis 60 mm long, lying, one of the triangular face of the square pyramid is lying on the ground, means on HP. Then the axis of this square pyramid, the axis of this square pyramid is also making 45 degrees with VP. With these two conditions, we need to draw the projections of the pyramid. Now, let us take XY line here. Let us take the XY line, of course. Then with this, I mean, we have already analyzed the problem. In this case, the base, that means the one of the base one of the base sides and one of the triangular face of the square pyramid is lying on the ground. That means HP, on the HP. Now we have to assume that the first step is that we have to draw the projections of the square pyramid when it is lying on HP. This is the first step. The first step is that assume that it is standing on VP because it is making some angle. Of course, it is lying on HP, but even though if it is making some angle also, we need to assume that. The first step is that we have to assume that from which reference plane it is making some angle. The first step is that we have to assume that it is standing on that plane. Assuming, draw the projections, assuming that that object is lying in HP. Now assume that this square pyramid is lying on HP, so that the top view is a square. It is a true shape. It is a true shape that you can see here. With side 40 mm, construct a square and join these diagonals to get the apex here. Then name all those points as A, B, C, D. Name these edges as A, B, C, D. So this is exactly the true shape. As I said in the last slide, when when an object is located on HP or on the ground, the top view will be the true shape. It is a square pyramid, so that we are getting top view as a square here. Then we will get an apex here because we have the four triangular faces. Finally, we will get an apex here. Then project these points onto the top, onto the XY line to get to draw the front view. Then join these two lines, then locate the height, which is at a height of 60 mm. Take the compass, take the scale, and get the point here at a height 60 mm. Join these 2 points to get the triangle. Then name all those points as A dash, B dash here. So the front of this square pyramid, the front point is B and the back point is B dash and A dash. The front point is C dash and the back point is D dash. Okay. Now this I am assuming as O dash here. So A dash, B dash, C dash, D dash, and O dash you have. Then the next step is exactly the square pyramid is not like this. We are assumed that this is lying on HP. Then we have drawn the projections of the square pyramid, assuming that the base is exactly lying on HP, which is not making any angle with HP. These are the simple projections. These are the assumed projections of the square pyramid with the given dimensions. Then actual condition, the actual given condition in the problem is, and the triangular face, one of the triangular face is lying on the ground. Now I'm twisting this front view and to the in such a way that one of the face is lying on the ground, that means on the HP. Now take a compass, okay, take a compass, then uh, take a compass, then locate a point O dash at a convenient point at a convenient location. Then draw a line which is having some inclination as with a compass. Okay. Then take the compass, then locate A dash, B dash, and C dash, D dash. The dimensions of this shape, and the dimensions of this shape is exactly similar. By using compass and transfer all the heights, and this will become front view of the component, which is the square pyramid when it is lying on HP. Then project all these points down, A dash, B dash, C dash, D dash, and O dash. Then A dash, we will get 1 point here. Then B and B, we will get 1 more point here, A and B. And similarly, then C and C, we will get 1 more point here, D and D. This is A, B, C, and D. So this is exactly the bottom of the square pyramid when we see from the top, when it is lying on the ground. One of the triangular face of the square pyramid lying on the ground, when we see from the top, it looks like this. Now project this point as O dash, then join all these the points, obtain points, then finally join O dash, that means it is the apex when you see from the top. Then these D and O, I mean D1 and O1 is a dotted line here because this A and B. Of course, this is AB, and C1 and O1. Of course, I am naming this as O1 here. C1 O1 is a dotted line because it is going backside to the back to the solid. Then O1 D1 is going backside to the solid, so that we need to represent that edge as a dotted line here. Now, this is the condition. This is exactly the condition when the square pyramid is lying. One of the triangular face of the square pyramid is lying on HP. In that case, this is the front view and this is the top view. Now the other condition given in this problem is the axis is making an angle. The axis of this triangular, the axis of this square pyramid is making an angle 45 degrees with HP. Take apex near to VP. That means apex should be near to this vertical plane, near to the plane. So that means we have to draw the projections such that the apex should be near to the plane, near to the vertical plane. Okay, draw a line at 45 degrees to VP. So this is exactly the line that you can see here, 45 degrees line. And with respect to locate one point O dash, then transfer all these distances and construct this shape exactly at an angle of 45 degrees. At an angle of 45 degrees. Okay, draw a 45 degrees line, then at this height, take the compass, locate this point, then get A1 B1 from the compass, then A1 D1, draw a perpendicular line, then B1 C1, which is perpendicular to A1 B1, join all these points. Similarly, join A1 O1, B1 O1, then join D1 O1 as a dotted line, O1 C1 as a dotted line. So the dimensions of the top view when the square pyramid is, one of the surface of the square pyramid is lying on the ground, the top view is similar as that of the axis of this pyramid is inclined to the 45 degrees with VP. Both the shapes are same. So these two shapes are same, these two shapes are same. Okay, so by using compass, we have to construct this shape, and by using compass and transfer all the heights to get this shape at an angle 45 degrees with VP. Okay, so now we have to get the front view when the axis of the square pyramid is making 45 degrees with VP. This is the top view, but we have not drawn the front view. So project all these points up, like this from A1, B1, C1 and D1, similarly from the O1, then project the points A dash, B dash, C dash, D dash, and as well as O dash. Then we will get, this is the D1 and D dash, we will get 1 point here. Then C1 and C dash, we will get 1 more point here. Then it is A1, A dash, we will get 1 more point here, and similarly we will get B1 point. And finally we will get the O1 and O dash here. I am naming this point as A1 dash, then this is D1 dash, this will be C1 dash and D1, B1 dash. Then we have A1 dash, B1 dash, C1 dash, then D1 dash, and finally we have O1 dash also. So join A1 dash, B1 dash, C1 dash, D1 dash to get the front view of the square pyramid when it is making at an angle of 45 degrees with VP. This is the front view of the square pyramid when it is making 45 degrees with VP, vertical plane, and this is the top view when a square pyramid, it is lying, one of the face of the square pyramid is lying on HP, as well as the axis of this pyramid is making 45 degrees with VP. This is the top view, this is the front view, and the second one, the second figure, I mean the second step figure is only when the axis of this square pyramid is, I mean one of the face of the square pyramid is lying on HP. This is what we have to draw. We have to analyze the problem to project to draw the projections of the given solid with the given conditions. I will stop here now, and in the next session I will discuss the few more problems with the given conditions. Thank you one and all. I will discuss few more topics, few more examples in the next session. Thank you.